Well, welcome to the second of three lectures of our series of 4D design catalysts who are visiting us this semester. And tonight we have the pleasure of welcoming Tomorrow Lab. Yay! Founded in 2010, Tomorrow Lab is a hardware innovation studio, and they create market-ready manufacturable products. Ted has a Master of Industrial Design from Georgia Tech, as well as a bachelor's in Inventive Design Engineering from Purdue University. And Pepin, who's a partner at Tomorrow Lab, and works on the entrepreneur side, the tech side, the mechanical, and you both work on all the stuff. He has a mechanical engineering degree from Columbia University and a degree in industrial design from La Scuola Politecnica di Milano.
The design in Milan.
The design in Milan. So Ted and Pepin have been friends of mine for a long time, over a decade. And I first met them when I was a visiting assistant professor at Georgia Tech. I first met Ted and then met Pepin through Ted. And we have been through lots of ringers together. We have shared studios. We have been neighbors. And for me, it was always really a pleasure to connect with like-minded folks who shared a passion for design technology, hardware, and software. And I have watched their studio grow from the very start to the burgeoning business that you will see they're going to talk about tonight. So without further ado, I will let Ted and Pepin share their story.
Thank you,
Great.
Carla.
Awesome. So over the last 3 days, we've been conducting a workshop with Carla's 4D students, the 4 dudes of 4D. And we've been reimagining everyday tech objects and trying to make them more personal. So this process started with a teardown. It's something that we celebrate in our work where you take an object, usually a technology or hardware product, and you take it apart and you see what's inside and you figure out how it works, and you use that technology to inspire you into new applications. And so what we wanted these students to do, these designers to do, was create new, more personal objects that had like a concept that was very much about them. And the results were pretty great, especially for a 3-day workshop. So I'll talk about Jerry and Chen first. Jerry created these glasses, and they're sort of an inversion of augmented reality glasses. So they're sort of like augmented personality glasses. And what they do is they take an image that's sort of parallel with your line of sight, and they cast it outward over your eyes. And so you can see just normal as the user, but everyone around you sees that image floating over your eyes. And so he made these angry glasses. And so like when you're having a bad crit, you can push a button and it makes you have red eyes. Chen created this sort of magical jellyfish drone. So he started with this monocopter. You guys have seen these like at festivals where like you push the button and you put your hand under it and it has flashy lights. And so he took that apart and reimagined it to be a jellyfish. And so when you approach the jellyfish, it gets really shy. And then when you walk away, it starts to like balloon up, and he's going to evolve that into an actual flying jellyfish.
Yeah. And then let's see, Michael, you can probably meet him after, but he was playing with audio, time, and distance using these really cool old Panasonic walkie-talkies and some directional speakers, and did this amazing performance using audio, sort of playing back the audio to himself. And then Stephen, who we thought was sort of stuck thinking about concepts the whole time, did something a little bit subversive, but it actually was adding ambient sounds to our own environment. So as we were saying certain words or doing certain things, he was triggering things remotely, these sounds in the background, including some air compressor noise and some other jiggling in a can. So that was fun. And it kind of sets up ourselves a little bit. So Carla introduced us, so we won't review that again. But before starting Tomorrow Lab, we each have our own story of coming to design and technology. So for myself, where I met Carl at Georgia Tech, I was coming out of an engineering program and into design, and I was really interested in the intersection of how design can be used to create products that are connected to the internet. This was the time that Arduino was sort of brand new, and you might call it interaction design. There's some other research done by Bill Mogridge looking at how we can move away from a graphical user interface of just images for controlling computers and more into tangible ones. And then I wanted to take a little bit step further by limiting that to just things that you could touch or objects that communicated information to you through their appearance. And so that led me to a certain amount of research, there's some precedence here. This Veilabot is a robot that both stood up when your instant messenger friend was there and fell over when they went away. This hard drive in the lower left, it twisted the more out of sync your files got with your backup. And all of these for me kind of represented this idea of like a moldy peach. You don't need a screen on the peach to tell you that it's molding. And that was sort of, I don't know, it was fascinating to me. How could electronics kind of carry that information in them? So I spent a year between the other studies just creating these playful prototypes that were Arduino controlled. And really the body of work was a collection of all these little videos and photos of physical ways to display this digital information.
Cool. Hi, I'm Pepin. Carla introduced my background. I was doing a lot of work at that same time period, much more object focused, much more static. I didn't know how Arduinos worked. I wanted to, and I'll get into that in a second. But I was much more focused on form and mechanics. In my master's work, I did a few projects. The first was called Flaminia Bosco. It was this idea around framing experiences in nature to create a more comfortable bathroom experience for people in transit. So if you think of a transit hub, there's going to be people from many different cultures, and so we took this Jungian idea of trying to find experiences that everyone had, experiences in nature, frame those into bathroom objects to make people feel more comfortable in those spaces. And I did a project called Schfood, which was around looking at different types of materials and using those materials to create transformations and mechanisms that kids could use with their gross motor skills to perform prep tasks in the kitchen so that we could get kids interested in cooking earlier. And then my postgraduate work, I did a bunch of work on this project called Contrail and a number of other urban hacks. And this Contrail piece was around turning your bicycle into a paintbrush, and I'll show you that in a second. So to highlight that, this is Flaminia Bosco. The shower piece, which was supposed to be for like a lounge shower, had these like this light gobo effect that made you feel like you were in a forest. And then I'm kind of like a big fan of dad jokes, and so are Italians, so they really gravitated towards this concept, which is called Pee on a Tree, and it's just a urinal that lets you pee on a tree. And then Contrail, this is this bike paintbrush that we developed. The idea here was that cyclists felt really outnumbered in spaces that they weren't actually outnumbered. The thing about a bike is that it moves quickly through a space, and so you really didn't have a great picture of any point in time of how many cyclists were using an area. So we thought, okay, if we could turn a bike into a paintbrush, we could mark the ground that they went on, and if a lot of people use this thing, then you'd get this beautiful set of contrails that showed the usage of that space, kind of like a psychogeography project. And I did this in partnership with my wife, Teresa. So I presented this at a thing called Williamsburg Walks, and Ted had actually hosted this with his group called Do Tank. And at the end of it, we sort of like walked up to each other like, what do you do? And Ted was like, sort of like design stuff, and I'm working on interesting startups in the city, and I was doing the same thing. And we took to this point of looking at each other's portfolios, and it was kind of like portfolio love. And we decided to start working on projects together, and that became Tomorrow Lab.
Yeah. So here's a video we'd like to show you that was created by Dropbox that tells you about us. Anytime a product is brought into the world, it is someone's responsibility. We really don't need more of everything. I think what we actually need are better things. As a design studio, I think that we have a different approach as far as how we want other people outside of our field to understand what we do as designers and engineers.
So we work on a wide array of products, things as sober as medication adherence to a lot of really fun stuff, agricultural sensors that can monitor soil conditions that promote organic farming. We created a new VR experience that projects an image on the inside of this visor, and what it allows you to do is feel like you're inside a spacesuit. By taking a lot of new technologies and applying them to human needs, we're able to create really impactful products in a variety of verticals.
With each project, we're trying to respect something, whether that's someone's time or their life or the environment. And I feel like if the products that we create aren't at least doing one good thing, then we're really not doing this right.
Every single product we develop here, we have industrial designers to sketch out the design. We have mechanical engineers on the team to figure out how everything could be assembled. And all of this require us to work really closely together, and we get inspired by each other and figure out the best solution to solve the problem.
We have a saying here, there's sort of like no such thing as thinking in a group. Thinking happens inside a person's head. And so we have to create tools and processes in which people can think together.
We're a small team that moves quickly, and we need to be able to share files from SolidWorks or 3D files to photography and video, all the way to electrical files. And none of that software is online. It's all desktop software, and it requires a lot of processing power. So really what Dropbox allows us to do is almost take that desktop software and turn it into a web app.
It recognizes that the purpose of a company is to stay in flow and try and get things done very quickly and move on to the next thing. And it lets everyone collaborate without things getting in the way.
We really like to work on products that are first of their category or first of their kind. Anytime we're designing a product, we are hoping that it is intuitive to people, that it's helpful, that the design is sort of uplifting and fun to use.
The future is somewhat of a scary place for some people. For me, the uncertainty that's involved with looking towards the future is the exciting part. It's very easy to become discouraged by the progress of climate change or social injustice, and it's sometimes hard to see how what we're creating always fits into that larger solution to fix those problems. At the same time, it's really important to focus on the specific thing that you're developing. And if you can move the needle just a little bit, doing that will help us have some perspective on what we're trying to build in the future.
Thank you, Dropbox, for making that video. That was like a lot of production that went into that, so thanks for bearing through the shilling part.
Two key ideas touched on there. We pride ourselves on fusing the technology and design process, and we pride ourselves on inventing. And we've specifically designed our staff to bring together mechanical engineering, electrical engineering, and design. And we really think that's the only way to really create new things.
Cool. And so a few points around that. We have this idea of shaping technology by design, and we think that's really what invention is. And we've created this essential process that we've branded as holistic innovation, and you'll see evidence of that throughout some of the case studies we show. Our offerings are scaled, so engaging with us as a consultancy looks like, it could be a short thing, about a day in which we would do a workshop. We can do things called invention sprints, where people will pose a problem to us, or they'll bring us a sort of partially baked idea, and then we'll spend 6 weeks turning that thing into something real, and usually creating proof of concept prototypes of the core invention. And then we do product development, and this is a more traditional process where we create a product requirements document. There's a lot of engineering involved, and it's about building this thing until it's ready for market.
The lab itself, so we have 2 floors located in Lower Manhattan in Chinatown. It's a very vibrant area of the city, and they're really set up for typical office space, but then we have some prototyping facilities. We host events, a pretty good amount of equipment. But one key aspect that we often get asked is sort of like, where is the factory? Because people see us developing products that get manufactured. But one of our core beliefs is we rely on our specifically China-based partners who have this amazing knowledge in manufacturing because it is the world's factory today. We have this belief that the sooner we can get the product design in the hands of a manufacturer, the more we're going to learn, the more the client is going to benefit, and the faster we can get that product to market. There's also just a reality being in Manhattan where, it's great for people to meet because it's very central and dense, but it's not a great place for a facility for a manufacturing plant. It's just a cost of real estate. But I think that challenge has actually proved to be a benefit as far as how we use resources.
There are anomalies in that, like Adafruit, who weirdly produces stuff, but it doesn't take as much space to do pick and place. Our clients are pretty diverse, but mostly what we're working with are venture-backed hardware startups. So this will usually be a team of a couple people in their very early stages who come to us and they want us to help them bring their product into reality. And they'll often have a good idea, but they won't really know how to bring it all the way to the end. Sometimes they'll have even engineers or industrial designers working with them, but they need to complete this picture because there are so many components to making a good product and there's so much experience that you're unlikely to bring together a brand new team that's worked together to launch something unless you hire that team, and that's us. We also work with corporate innovation groups. These are teams within companies that are designed to sort of like disrupt those companies or create new products for them to put out. And then every once in a while we work with advertising agencies, and that'll be a product like the helmet you're going to see later. We look for very specific things in the teams that come to us. We want to see an idea that is first of its kind. We're really unlikely to find any value in creating sort of a repeat follow-on product unless there's some really interesting feature to solve. It's not because we're snobs about products, although we are. It's because that's just not where we create value, and it would just be crazy to have someone like Jing Wen, who you saw working on creating something that's already been made before. Her skill set is all around invention. We also want to know that you have access to funding, not just because we're greedy, but because we know that there's going to be this point where this has to become real, and if you don't have that funding or you don't have the ability to get something funded, it's just not going to be able to take on a life of its own. We want to see expertise in the domain that you're entering, just like the venture capital groups that fund things. We want to know that the people we're working with are experts, that they have just an incredible insight in what they're trying to build. We want startups that have at least 2 to 3 people. We occasionally work with sole inventors, but sole inventors have a very, very hard time bringing on additional people throughout this process. They become overloaded. And so unless you have a couple people working on this to begin with, you're going to be overburdened with the process. And once again, we end up in that place where this thing just can't grow wings and fly. We like people who have a very flexible approach. Part of the process of invention is learning what's wrong. And if you get bound up in exactly what you're expecting something to be, you're never going to be able to reveal what it's going to be. And lastly, we really like people who know what they don't know, or at least are really comfortable with the idea of things that they don't know. Our process of invention is all about experimentation and exploration, and it's all about venturing into the unknown. One of the things that will drive us insane in an early process is a client who's like, yeah, well, I know this already, or I'm an expert in this, to the point where I'm not interested in the insights that we're creating through this process. It's just not going to be, fruitful going forward.
Just of note, those bullet points, really just the first one deals with the actual idea, and the rest are about the people. So, and while we're not, an agency that is meant to create cultural change or, build startups, I think we kind of do it anyway through, our approach, helping, teach our style of invention to startups specifically. It's pretty critical.
Invention is people.
Yeah.
Yeah. There you go.
This is a little bit just about our history. We got started in 2010, a year after, it was around 2009 when we met, and we've scaled from Pepin and I to, we now have over 12 people, And in New York, we have partners who are located in Asia. I'm thankful we've been able to do this through, I guess, luck and some hard work.
It's a fair amount of hard work.
Yeah.
Cool. And so our culture, we're looking for these like hybrid people. This is sort of a key part of our personalities, and we think it's the personality that makes a great inventor, is someone who can hold a couple disciplines in their head at the same time and see the magic that happens within their own brain and like pick out ideas from that. So almost everyone we hire has the title of a design engineer, and they almost all have backgrounds of design and engineering.
Right. The organization is very flat. So, Pepin and I interface with each of the clients as the partners. Really, anyone is encouraged and allowed to participate. So, just because the electrical engineer has that, role or title, that doesn't mean they can't contribute to the mechanism brainstorm. And, this kind of idea is an energy that we want to cultivate not only in our space, but we really think this is something that, can grow and stand for more. That's also done with our sort of obsessive prototyping, which explains itself in its title. But we have this idea that if you can hold a prototype, that's worth a 100-page PowerPoint. And so we really try to convince people we're working with of that. And even if it's the wrong thing, knowing and being able to show that it's the wrong thing to a business who might otherwise spend millions of dollars and months going down the wrong path is valuable.
And then the last bit is like, how do we sort of pick our projects? We're looking for something that we're really passionate about. There's a lot of spaces that inspire us. As we mentioned in that video, we want to see things that move the needle, like socially, environmentally, or that are just like delightful. We love intellectual property. We want to be in the space where new IP is being created. And also to fund those things, we will also accept crazy money. So I'm going to talk a little bit about invention, because I think it's a term that we've lost a little bit and has sort of given a lot of birth to this newer term called innovation. And so there are a lot of innovation agencies out there. I've worked for them. We thought of framing ourselves as an innovation agency. There's a lot of money for that term. And what we see innovation really being is this idea of defining the way forward. And it's very strategy focused for that reason. We see it being explicitly cross-functional. Whenever you're working with an innovation agency or you're working with an innovation function within a company, they're demanding that sort of everyone be involved, right? This is about getting buy-in from all of the key stakeholders across the company. There has to be someone from every department contributing to decision-making. And the goal of innovation is this idea of business success, right? You want to make sure that something is desirable for a consumer and is feasible from an engineering standpoint of view and is viable from a business standpoint. But in general, the goal is a financial one. You want to create innovations that drive dollar sign growth into a company. And that's fine, but that's not what we were really good at. And so when we tried to frame ourselves as an innovation agency, it didn't really fit. And what we realized what we were doing was we were creating inventions. And while an innovation is about the way of doing something, the invention is about the thing that you're creating. And so for us, that means that we're creating innovations, but they're object-focused. They're implicitly cross-functional, which means that we can take people from any point in a company and get insight from them, and we can create insights from any kind of stakeholder. But the idea of putting someone in the room who isn't particularly fond of working on the idea, or the idea of bringing anyone in who's not going to actually generate a lot of momentum in the process is really forbidden. So you can be part of it, but you don't have to be part of it. And if you don't want to be part of it, please don't be. We're prototype driven. So we're all about the idea of making something real and seeing what happens when it's real. And the goal for us is just making things that work, right? It's about form and function. It's about it existing in the world. And it's about knowing that it does a thing. So we think that invention can be a form of craft. We know that invention can be a culture. So this, art school is a great example of a culture of invention. I like saying that the way you create a culture of invention is you take time and space and money and you give it to people who want to create new things, and then you take away time, space, and money and create a little pressure cooker, and you'll see great things come out of that. We know that invention can be a discipline, but we're not really sure what that discipline is yet. There is, of course, your program that was inventive design, or inventive engineering, sorry, or inventive design engineering. But it's pretty undefined. So, looking at other disciplines, science is about observation and experimentation in the natural world. Engineering is about applying science and creating best practices and equations for figuring out how to make a thing work. Design's all about definition and doing research and being creative and defining like what an object or an experience is. And then art is all about the exploration of new practices and creativity driven by materials. And I really hung on to that idea of materials because I think that invention can be a craft form. And in that craft form, what we do is we look for the widest variety of materials. And so for Tomorrow Lab, those materials are about mechanisms. Those materials are around electronics. Those materials can be very literal, like plastics and metals, which we're very good at manipulating. And they can be much more abstract, like data, which we're also really good at working with. And what we want to do is we want to take ourselves and give ourselves the highest level of competence in those materials. We want to have the most precise expression of our creative instincts in those materials. And then we want to develop a quickness and a confidence in them. And the idea of like any craftsperson is to become a master in their craft. And so we want to become master craftsmen and craftspeople in invention. And we kind of like have a process, like some steps that we can do to become really good at inventing. So the first thing is you select the materials. I've mentioned the ones that we're interested in, but if you want to be an inventor around plastics, we saw Cody's work today, and like he's like looking at HDPE, a very specific plastic, and he's learning all of the ways to manipulate this material and all the variations in that. It's a very literal material. But he's also learning about all the robotics and the materials that drive manipulating that. And then you want to take your sort of material and you want to practice and prototype with it because you want to gain a level of comfort and you want to start to see gesture in your work and stroke in your work. The idea is that when you start manipulating these materials and you start seeing the results of working very quickly in them, you can kind of start to see your groove and your level of interest in what you're really able to produce quickly. And that's sort of a sign of your trajectory within that space. We then use design to create parameters, and you use science to conduct research on those materials, and you also use design and science to see how those how they weigh on people and how they, how people interact with them. And then you want to, in our case, evolve those prototypes into products. And the reason for doing that is because our objective is still invention, right? And the idea of just creating prototypes for the heck of it, that is fun as sort of a design and maybe an artistic exercise, but a true inventor, the true idea of invention is to create useful and helpful things in the universe. And then next, we want to work with larger and larger teams to extend our competence. And so that was that intersection between Ted and I, right? I had learned a lot about how to manipulate materials and use design to create objects, and I was really into inventing new things like that contrail thing you saw. Ted was really into inventing new interfaces, and we saw, oh wow, if we combine these competencies and we take these two inventors and we put them together, we can invent really interesting hardware products. And so that's how we were able to build an invention lab for hardware products. And then the big goal here is to sort of like take that pairing and start bringing in other people who have other inventive skills and who know their own materials. And if that sort of group can grow big enough and can be really good at collaborating, eventually we can start creating new technologies. And that's really nice because those things are the fundamental stuff that changes things, right? A fundamental new technology might be a new form of energy production. It might be a new way of recycling things. It can actually maybe help. So we have tiers of invention that we work with, and as we go through our case studies, we're going to talk about those tiers. This is a revelation we had not but like a month ago, which is we had been selling these invention sprints for about 1.5 years, and we were realizing that some were easier and some were harder. That's not a difficult insight to come to, but it was one for us. So for us, the idea of a tier 1, I've explained it here in question marks and swear words. So a tier 1 is when you're reconfiguring some technology and you're designing it into an application. It's really the heart of industrial design as a discipline. Tier 2 is adapting a technology into a different domain. This is when something used to be used in one space and now it's going to be used in another, and you really have to start to understand the engineering parameters to make that fit. So that might be making something smaller, or it might be making it waterproof. Tier 3 is where it really starts to get difficult. This is when there are a lot of invention steps, a lot of ideas that separate the technology as it was meant to be used and the place that it's going to be used. This is where components are being taught new tricks. So an example of this is we took a vibrational sensor that was used for, usually used in wearables to know if you're running, and we taught it to tell us if there was water moving through a pipe. In these cases, you end up with a lot of inventions that sort of glue the big idea onto the thing that it's trying to measure in this case. There are some precedents, usually some patents, but you're doing a lot of the inventing and creating a lot of the big IP steps. And then tier 4 is the really scary place. This is where there are no precedents, there are no patents, or the patents are very sketchy. Sometimes there's just rumors. We don't know if it's possible. Right now we have a thing in our lab right now where we're trying to put out fires with sound waves. That might not turn out to be a thing. There are rumors that this is possible. We've seen prototypes that do it at very short distances. We're not sure if we're just blowing out the fire like you would with your breath with the sound waves, or if we're employing any number of these theoretical systems, like physical systems that would be causing the fire to go out. So we're building lots of prototypes, and we're exploring it from 12 different angles.
Right. Yeah, I guess, before we move on to the case studies, one important sort of notion here is that, as Pepin said, there are 4 tiers. Sometimes we don't know what tier we're at when we start, which can be painful from a business standpoint because time is money. And also, I think another thing that I keep learning over and over is that a patent doesn't mean that it works. You can write on paper the idea of a perpetual motion machine and submit that to the USPTO and get a nice document, but when it comes into our world, when we're trying to use that into real products, we may say, wow, this is bullshit, right? And that we're finding a little bit of that with this project, with the sound.
Piece of trivia, the one thing you can't patent is a perpetual motion machine.
Okay, so that's a bad example.
That's explicitly one thing, because they used to get like 1 million patents for perpetual motion machines, but it's a good example, right?
So we're going to go through pretty quickly some case studies from our portfolio, and with each of these, there's a tier we've assigned. So this is Hammerhead. This is a navigation device for bicyclists, and this is a sort of a tier 1 product. It has an accelerometer in it, some other sensors like light sensors. The whole point is to create a safer and easier way for bicyclists to navigate. It connects over Bluetooth to your phone, and there's an app that you can set your destination to, and it gives you turn-by-turn directions on your way there. There's also racing functions built in and some social connectivity. This was a group of entrepreneurs who were really bike heads, or bike nuts. We are too, kind of. So
there's some innovation in there around the display and how it moves.
Right.
But it's like once you had that idea, there was nothing sort of difficult about implementing that.
Right.
Yeah.
Sort of combining them. This is Jump Bikes, which is it's a bike sharing service owned by Uber. You can find them in several cities around the world. So in 2017, we helped redesign their checkout process and checkout interface. And in this case, everything is touch and NFC enabled. We have a spot for your phone to clip in. And our relationship with Jump actually goes back farther. So starting in 2010, They were called Social Bicycles, and I had met the founder, Ryan, who was a city planner, and he had this idea and a patent for a bike sharing system. And the initial notion, as shown on the lower left, was a device that could mount to any bike and turn it into a bike sharing bike. And we pitched this to the city of Copenhagen and some others in the US. And slowly he had built the business and was able to raise capital. We did evolve the design up until the point where the social bicycle bikes that you can find in a lot of cities have this touch interface, but they did find that it was more economical to actually own and design the whole bike as opposed to just the thing that makes any bike a bike sharing bike. This bicycle also is a dockless style, meaning you can lock it anywhere, including bike racks that others can use. And that is in contrast to a docked-based system like City Bike or Capital Bike Share in Chicago, which has the dedicated racks there. Yeah. Last sort of transportation project is called Waycount. So Waycount is a traffic counter. Most people are not familiar with them, although they've seen or driven over those rubber tubes in the road. And so those rubber tubes are put there by the city. And they're actually, all cities in the US are mandated to gather traffic count data to get access to federal highway funding to do street improvements. And so what we did is several years ago, we used an Arduino and a pressure sensor to use this to measure bikes. And we took this actually to Moscow, to an architecture institute there, to use it to measure vehicles to see where bike lanes would be a good idea or a bad idea. And later we found there was some business traction for this, so we stuffed the circuit inside of these homemade, it almost looks like a bomb, but these containers, and we sold a few, built a website around it, and we later evolved that into a more custom version. The other important thing here is, and what makes this kind of a tier 2, the data component is pretty special. We decided to make the data that you extract open and accessible by anyone through the internet. So if you go to waycount.com, not only do you access your data there, but anyone can go on and see what is the traffic at any specific block that someone is using this. So we have this sort of big idea that we can influence city design and street design all over the world by sharing the data.
Cool. So this is a big pivot from traffic counting. This is a Sperm Preservation Kit we created for a company called Daddy. We did not brand them. That is not our name, but it's a good name.
It's catchy.
It's catchy. So Daddy is a kit that you use at home. In the fertility world, fertility is basically a problem shared by men and women almost equally. So if there is a biological cause, half the time it's related to men, half the time it's related to women. A third of the time it's both. You do the math. Okay, so the way this works is we created a pod that you create a sample in. You'll appreciate the euphemism. You close it, you push a button on the top, it releases a preservative inside the cup. And then you put it in this box, you close it, and you mail it off. It's really designed to be almost like a Apple-like packaging experience, and that's actually on purpose. The two founders, or the founder and the chief operating officer, come from Apple. And they were really obsessed with this becoming a really beautiful consumer experience. And so we did a lot of design work to do that, but we did even more design work to adapt technologies inside. And so what you don't see on the outside is what's running on the inside. And so inside that box, we created a chemical refrigerator using a technology called phase change material and a type of thermal insulation called vacuum insulated panels. And what we're able to do is create a box that's about this big that is essentially a chemically powered refrigerator, and it keeps the sperm preserved for 48 hours in shipment. And so in the past, they had home sperm sampling kits, and it looked a lot like what you might pull like a wine bottle, like if you ordered a fancy bottle of wine that came in like a refrigerated package. A lot of foam bits and like a lot of mylar shininess, and we tried to hide all that away, and we did a lot of work to make this fit into a simple package. And that's where a lot of the difficulty of inventing this went. The technologies were already there. PCM has existed, these VIPs existed, deployable caps that pop and let material out exist. But no one had done it in a way that was sort of really visually appealing, that was small enough to fit in a backpack. And so that's where we spent a lot of our time innovating. This is the long-promised case study on our space helmet. So we created this thing called an astronaut reality helmet. It's basically a VR experience. We created this for a TV show called One Strange Rock. One Strange Rock was a show hosted by Will Smith on National Geographic, and the show's purpose was to show people what it was like to see the Earth from space. And so they interviewed dozens of astronauts about their experiences in space, and they talked about science lessons and lessons in ecology that you sort of see actually looking at the Earth. And the hope was to get people to really feel almost viscerally this idea of our planet as a closed and very delicate but also very powerful ecosystem. To promote this show, we created these space helmets with the agency McCann, New York. And their idea was to put some OLED screens in front of your face and kind of like, get a feel of being in a space helmet. We realized that wasn't technically feasible, and so we did a bunch of technology research for them over the course of a very short period of time, about 2 weeks, and we landed on a solution where we were able to take a laser projector, a lens array, and a spherical screen, a hemispherical screen, and place that in front of your face and give you this like mini Omnimax experience. There's a critical size that we had to discover. Too close to your face and you want to throw up, too far away from your face and you're wearing like a giant bubble. And while these are somewhat ridiculously large, I think we found a happy medium. We then went and built 25 of these for an event. And the build was I think wildly successful. Usually when you agree to do something in the course of 2 months, you're panicking the whole time. We used a lot of these skills, and this is one of those first moments where we realized that we were kind of becoming masters of this craft form. Like in 2 months, we were able to build 25 of these, and they went together and they worked really well. Part of that was knowing good tolerances and doing like good engineering around the pivot and the way this helmet worked. A lot of it was making sure that we had prototyped the basics of it to death over the course of a few days, and making sure that we just had a really good rigid system. But when all these parts came in from fabricators on the West Coast and the East Coast and Amish country, it was Chinese New Year, so we used our domestic network. All of it went together rather beautifully. And so we had this event, and these 25 helmets were put onto reporters' heads. This is Kevin, who's the client's client, Ben, who is an intern, Christine, who is our client, Courtney, who is our client, that's me. We're panicking in the back row because there's this iPad, and you push a button on the iPad, and these 25 kind of hard-scrabble tech reporters and environmental reporters are have these things on it, and they all start to play at the same moment. And they did. We also built provisions in this because when the reporter from Engadget, his helmet malfunctioned, we designed it so that I could sneak up behind him and I could slide out the projector and slide in a new one, and he had no idea what happened. And so, we're starting to get good at this. Yeah.
These, although these were created just for this event, obviously there was a lot of interest and attention after, and so these have traveled to Japan for a TV Asahi festival, to space museums in New York and New Jersey, and they've kind of somehow lived a long life, even though they were created with rapid prototyping processes.
There's layers of hot glue keeping them together at this point too.
So one of the last case studies is Terralytic. This is a New York-based startup. They create agricultural soil sensors. So this is a stake that gets buried in the ground. It's about 3 feet long, and it's packed with 24 sensors. So it's really measuring almost everything you can measure and want to know about soil, from temperature, humidity, nitrogen, phosphate, potassium, we even have some gas sensors in here to watch the soil breathe with CO2 and oxygen. And the customer for this is obviously not, us in this room. They're corporate agricultural farm owners. So, Dole or Tropicana, or where the potatoes for McDonald's French fries are grown. This is sort of like the market for them. There's a lot of food waste if the crops die, right? So a little bit about the product. There's 3 sensor nodes that are at specific depths, and there's a detachable head. That head uses this LoRa technology that's got a couple mile range, sort of like cellular, but you get to own the network that you build. And where we started this process is shown on the left. We went Amazon shopping and found, okay, what are inexpensive sensors that we could start with to understand how to measure oxygen or EC or pH. And we started to bring these together. We set up soil columns in our lab and really started to understand what worked and what didn't. Between the first and second images here, probably a couple months of work, but we started to figure out, okay, we have the sensor package, now how do we combine and miniaturize them? How do we create the nodes that expose themselves to the soil? And then how does that node fit into the stake body? This was these sensor nodes were sort of conceived of like razor blades. So you would buy the stake, but the nodes would eventually wear out over time, so they needed to be swapped. And
just a close-up of how those sensor nodes evolved.
Yeah.
We were looking at different technologies as this went along, and so these are first, second, third generation of the design. And sort of at the end, I think we kind of like nailed this thing as a razor blade.
I think so.
Yeah. And there are complicated reasons related to reference electrodes and things like that, why that sort of shape came about, but it represents just a ridiculous amount of work.
And for us, what makes this a tier 4 product, so while we were doing lab inventing, there was another group who was doing almost even more. And you can see in the image on the right, there are these little, almost looks like rice grains. So those are what are called ChemFETs, and this is a close-up of a diagram of a ChemFET. So if you're familiar with a MOSFET, this is a chemical version of it. So it has reactive chemical that's impregnated in the substrate. Then when it's exposed to a chemical of your choosing that you've designed for, the resistance changes, and then you're able to measure the amount of it in the soil. And what this looks like is this. So this is a zoom in of these tiny chips. They're the size of a rice grain. They're doing this crazy wire bonding onto the actual device here. Then those are coated in an epoxy.
Robotically, they created a little
thing, right?
Little epoxy robot to do it.
And then those drop into our razor blade. And so, this is a lab in California who Terralytic partnered with. For us, I think that we would love to be doing stuff at this scale, and maybe eventually we will. It requires an extraordinary amount of kind of expertise from all kinds. Chemistry, soil science, mechanical engineering, electrical engineering, and a lot of patience.
This is also an example of like our dream scenario. We've created this little orbit around ourselves, and that's our dozen designers who all have incredible abilities to invent things and augment our ability to invent things. And so Tomorrow Lab can invent, but when you can bring in another lab that's really collaborative, that has another completely different set of skills, like suddenly we're designing the big thing with the head and the latches and the connectivity and a lot of the sensors, and then they're able to design something at a very different scale, and suddenly this technology goes from being something that sort of knows that the ground is wet and works pretty well to something that has absolutely transformative ability to change how we do agriculture. Just to give you an idea of like the impact of a device like this, you can cut watering in half, which means you can cut runoff in half, you can cut fertilizer use in half. It totally changes the way that you can grow crops. And because we have this sort of organic monitor, you can use less of those things further still, because you can actually keep your soil alive and active. It could be a big deal. We're hoping it is. Okay.
All right, so Yeah. So for the last section of our talk, we just wanted to talk about what's next and where we're headed. So, we've been in business for 10 years and growing. And some questions that we grapple with are, what if we leverage our brand beyond just, our walls? What if we can stand for something larger than ourselves and get people excited about maybe our discipline or larger ideas that we stand for? And so 4 sort of areas that we are working on. First, a couple years ago, we set up a separate entity that really fabricates all of our products. So Tomorrow Lab designs and Made Today fabricates. And actually this split is something that our accountants really like, but also allows us to, after we've designed Terralytic, people can come back and sort of go shopping at Made Today. And this, design and fabrication split is something that seems to be working out. We also have been focusing on more of education, offering, nuggets of our approach and our invention style in workshops. We have finally second to last, this workforce development area, which we'll show 2 videos on. So we ran educational programs this summer for both graduates of design and engineering programs and also high schoolers from the Bronx. And lastly, we're looking at content. So
I hear it's king.
Sorry. We write and produce and broadcast on the internet our own Teardown series, and we try to really own the media side of what our brand stands for. So we're going to show you just a little bit about the last 2 now.
Cool. So So this program was led by Joe Gonzalez, who's an industrial designer, has been with us since he graduated from Parsons. And he's from the Bronx, and he wanted to build this program that could basically introduce students who were like him to industrial design. He found that there were really very few resources that he encountered in his time up there. And so he worked with the Bronx Innovation Factory, which is an MIT program, which is basically a fab lab in the Bronx, to introduce these students to the process of industrial design. And we had this great big crit at the end. David from Smart Design joined us, which is kind of like a New York design celebrity. And so we were really, really happy with the results of that. There was incredible process that came out of that, sort of more process than I've seen from industrial design graduates from undergrad programs. So we were just like really jazzed by that. And the students got a ton out of it. And then this is the Forward Fellowship, which I helped run.
The idea originally was pretty broad. There was these concepts of city learning, education, and development. And then throughout the research and the decision process, we got into like the whole thing of like food distribution. These things just kept on adding up until we got to the conclusion of deciding to making a board game.
We really wanted our board game to be a way to kind of like embody like the movement of the food and like the strategy behind how that gets from the farm to the grocery store, and hopefully just spark some interest so that later high school students can be like, how does the food system work, and just have it be like an entry point into learning more about where food comes from.
We hope this game doesn't feel educational, like intense educational, but the content somehow sneak in the game, and the aesthetic we are trying to achieve is to feel a little bit connect to the farm, the land.
Even though it's like daunting to be like, I've never done something like board game design, it was like the project that we thought would be most successful in accomplishing our mission. So just having that frame of mind where it's like, yeah, we don't really know much about this, but we think this achieves our goals in the best way, and being able to talk to the right people, discover the right resources, and pull that all together has probably been the most useful skill that I think I can take into the future, and probably what I would say is the most, the biggest like learning point of this experience, yeah.
So yeah, that was 3 months, and I mean, they just ended up creating a really beautiful piece in the end. The did a ton of playtesting at NYU and were able to create like a genuinely interesting board game. It's really hard to create a board game. I didn't know that, or I would have shooed them away from this, but they really pulled through.
Okay. So we talked about educational media. So we have a YouTube channel, by the way. You should subscribe. You might like it, or maybe your kids. The age we're trying to target is like 5 to 95. It's everybody. The series is called The Teardown. So we have this methodology that we found out that we were doing in our own work, and we said, why don't we film ourselves taking products apart, talking to the camera, and explaining what's in it, and maybe people want to watch that. So we now have a creative content producer. So we've brought on this guy, Andrew James Benson, he has won Emmys and Addies. He now shoots us, and we bring on guests. The video you're seeing here is one that Pepin and I were doing when it was just us filming these. But yeah, the intent here is to find products on the market people might find interesting, open them up, and kind of, for me, it's kind of like Mr. Wizard, or maybe there's these TV shows you watched when you were younger, where they're trying to explain and spark interest in what otherwise might be these like black box concepts to a lot of people. And so, with this educational media as well as the two programs, we're really trying to, educate and broaden the idea of engineering and what design can do for people to try to get them involved. If you want to be on the show or have ideas, you should let us know. A lot of this is trying to, find the intersection of what people find interesting with what we can, find little educational tidbits to talk about. All right, last section.
All right, so we're going to talk about where we're going next, and this is sort of a big idea for us. There are other venture studios out there. Most of them are focused on uncovering new innovation potential in existing products. Usually when you see the result of an invention studio, it's a product you've heard of, rebranded in a very millennial way. So an example of that is Quip. It's a vibrating toothbrush, but we gave it like a really sexy millennial brand, and now it's like a delivery service. We realized that we were creating a lot of value for our customers, and we've been trying to capture more of that value. And then we started to realize that maybe we wanted to be the genesis of ideas as well, and capture even more of that, because I've got to send my kids to college. And so what this looks like for Tomorrow Lab as a venture studio is we want to be working with brands still and getting insights from them. But instead of like getting them to come to us with a product idea and then us sell them design services back, we want to sell them a solution. We want to sell them something that's already been developed internally. And because it's developed internally, two things will happen. One, there'll be less panic, right? We're not going to be dealing with their timelines and their sort of like complexities. We're going to be dealing with our own timelines. And then the second piece is, because it came from us, we get to own a lot more of it. And the way that we imagine that working is we generate ideas internally, or we generate ideas in partnership with other inventors. And then we help them spin up either a company to create solutions, or we package that IP and sell it directly in. And then we do some design work to sort of fit it to the company that we're developing it for.
There's, we'll walk you through an example here. I think, we're working on this, and we've debated different forms of this over the past year and a half. I think that while kind of the market, I think, drove how we formed Tomorrow Lab as it is today, doing this may mean that we kind of have to almost create a new market of sorts. It represents for us, we're still doing technology and IP development, prototyping, industrial design, and the engineering and research. But again, as Pepin said, like we get to own that. And the core challenge is one, finding a customer who is wanting that technology, and then two, in some ways, if we have to, creating spin-off companies. So I want to take you through one of the projects we're working on right now. And it's an e-scooter. And I want to just start back with kind of where e-scooters of themselves have come from. So we're familiar with bike sharing, which is now around the world. It's over in over 400 cities. Actually, most are in China. U.S. is the second in running. There's many in Europe. There's a lot of bikes, and it's great for many reasons. Global warming, one. The shape of our cities and how we get around. I think generally people are happy with the infrastructure that is being built, and so bike sharing is great not only because of the convenience of it, but also the effect it's had on our cities. And that's actually very important, as we found out, for e-scooters. But there's some bad and surprising data after looking into this more, and that was that bike sharing systems kind of peaked in 2014. These are global installs of them around the world. And since then, they've gone to zero. There's no new systems being installed. And furthermore, in certain cities around the world, there's just too many bikes that are being used, maybe falling apart and being wasted. This is a real photo that exists in Wuhan of this bike graveyard of bike sharing bikes. So there's that information. So the question is why did this happen? Obviously, people are using the systems, but why did they stop installing? One idea is, the e-scooters came along, and they've maybe assumed a lot of the new growth in the sharing market. There's also been increases in rideshare, like with Lyft and Uber. So we looked at both of these and said, maybe sharing as a whole is not a great concept for e-scooters. So that led us onto the path of, okay, e-scooters are great. Let's see if we can come up with a design that's good for personal ownership. In the electric mobility area, this is kind of the landscape of it. You have skateboards all the way to e-bikes. There's this sort of sweet spot in the middle where a product that's around $500 that is, I can get you, up to 15 miles on a charge, that can be light to carry. 25 pounds is not that light, but it's a lot lighter than 70 pounds. This also, from a safety standpoint, we think is way safer than these one wheels and e-skateboards. So it's kind of like a really interesting concept. The other thing is that while bicycles came before bike sharing, e-scooters didn't really come before e-scooter sharing. So when we talk to people about this idea, they kind of lump the two together. They see the scooter and then they pair it in their mind with the service, but we're trying to sort of decouple it. And we're saying that actually personal ownership of e-scooter might be great for cities, it might be great for suburbs. And what if we can create almost like a new car that is low cost and portable? It's a few other facts. E-scooters you see a lot of kids on them. My nieces ride them. All of her friends have those. They're really easy to learn. They're also safer in a lot of ways than a bicycle. If you're ever in a tricky situation, you can step off instead of having to, jump off because you're not straddling something. There's also this trove of old photos we found that was sort of shocking. I think seeing these, we thought these were photoshopped. But the e-scooter technology has been around since the early 20th century, and there's this is Amelia Earhart in the middle with her pupil. These are some policemen riding them, and I think the only major upgrade here is that while they were using gasoline before, the motor is now small enough where it can be embedded in the wheel of the e-scooter. So we're giving it a shot, and in our spare time between our other client projects, we're kind of designing this product. And so furthermore, the competitors today are kind of focused on fast, heavy vehicles that don't fold that well. In fact, they seem to fold to just fit in car trunks better. But where we live and where a lot of people live in the world, this is how you get around. You walk or you shove yourself into subways. So things that are easy and balanced to carry, lightweight, etc., seems to be the way to go. So this is our design at the moment. Just some key aspects of it. It's made from, in the same way that bicycles are made. So there's bent tube. There's a wood deck, which we can get some suspension and lightness from. We have air-filled wheels. It has this sort of U shape at the top, which allows the rear wheel to fold through itself, and that allows us to get a more balanced geometry when folded. And we have these handles in the specific carrying positions that are right at the center of mass. So, in this image here, if you lift in the center, you're carrying it, balanced here, and then we're positioning the other handle in the center of mass this way. It's surprising to hear, but there's really no other scooters that have handles on them, or even ones in good places. Beyond that, this idea of maybe these are the way people get around in the future. These are everywhere. We kind of need a way to secure them. So we've built this locking cassette that has the key built into it. This is how you fold and unfold it. So you can't ride it without the key because you can't unfold it. It has a spring mechanism that helps sort of latch it up. It's really secure. And, we're just taking a minimal approach to the interface as far as showing the battery and the speed. There's a lot of really bad examples we found of, sort of taking references from the car world. But what we realized is, like in a bicycle, you don't need a speedometer to know when you feel unsafe. And it's really a learned intuition about, maybe it's, at 4 dots, that's my max speed that I feel comfortable. So we're kind of going with this idea. Yeah. So that's it.
That's it. All right.
Thanks so much.